Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in CSE. So in this video I'm going to discuss about example of distress algorithm. So normally a graph is nothing but collection of vertices and nodes, and mainly are going to have two different types of graph traversals, so breadth first search and depth first search. So in breadth first search we are going to be used the queue data structure, whereas in depth first search we are going to be used a stack data structure. So the graphs are mostly interesting data structure in computer science, and these graphs and trees are similar in structure, but there should be a little difference in this one. So when it comes to tree, it should be a set of vertices, nodes, and branches. So whereas in graphs, it should be a collection of vertices and edges. So there are two types of graph traversals: breadth first search and depth first search. So in this breadth first search, so we have to visit the nodes level by level by starting at level 0. So it should be which is nothing but a root node, and then we are going to move on to the next level. So in depth first search, we have to visit the root node first, and from this we have to be find out the childrens until it is going to be reach the ending node. So in breadth first search, we are going to use the two data structure, whereas in depth first search, we are going to use stack data structure. And in this one graphs, so the spanning tree is another concept. So the spanning tree is nothing but a connected undirected graph. So where this connected graph is nothing but every node is reachable from every node, and then undirected means the edges does not have any kind of associated direction. So in mathematical field of graph theory, the spanning tree of the graph is a connected subgraph, so in which there are no cycles here. So the spanning tree of the graph has no cycles, but it's still connected to the every vertex. So if G is the connected graph with n vertices and n edges, then the spanning tree of the graph G must have n minus 1 edges, and the number of edges deleted from G must be n minus 1 into n minus 1. That should be m minus n plus 1. Suppose a graph has many spanning trees, so by looking at this one, so I can able to construct different types of spanning trees here. So the spanning tree is of a graph is a connected subgraph which does not have any kind of cycles, and they're going to have different types of algorithms that are available for constructing this spanning tree. So if a graph is said to be connected with n vertices and n edges, then I can able to set that there should be a number of edges deleted from the graph G must be n minus n plus 1. So finding a spanning tree. So for finding this spanning tree, so initially how do we pick up initial node and then call it from the part of the spanning tree. So we're here, if I'm going to have undirected graph, so the possible spanning trees I can able to construct from the graph will be like this. So it should be one of the spanning tree that should be constructed by using of breadth first search, and this is the another spanning tree that I can able to construct it from the concept of depth first search. So minimizing costs. So here mainly this one is going to be used in many applications like electrical power, water, sewage lines, and telephone lines. So mainly for minimizing cost, this spanning tree application is going to be used. And to reduce the cost further, you can able to connect the houses in the form of a minimum cost spanning tree. So the minimum cost spanning tree is the spanning tree of connected undirected graph that is going to have the lowest cost here. If a graph is going to have n vertices, then each spanning tree is going to have n vertices and n minus 1 edges. Suppose if I'm going to have a connected graph like this, considering an example like so A, B, C, D. So if this is the graph, so based on that I can able to connect this spanning tree construction. So initially make a set of vertices here, and then select those minimum edges and check it out whether any cycle is forming or not. If I'm going to construct this, so cycle is going to be formed, so that's why I want to remove this. So next one 5, so cycle is forming, and 6, cycle is forming. So this should be the minimum spanning tree of the given graph. So in similar fashion, so this should be the given undirected graph. So I want to find the shortest path, new spanning tree from the given graph. So by considering the weights or cost here, let us assume that these are the houses that are connecting. So what is the minimum uh, cost for the implementing this telephone lines and all? So for this one, so how to choose this among all this one. So how I'm going to construct the minimum spanning tree from the given set of from the given graph. So let us consider A, B, C, D, E, and F. So for this, so initially I'm going to select what are the minimum weight costs according to some particular algorithm. So among all this, the 5 is minimum, so that's why I'm going to select 5 first. Among this, what should be the next minimum weight that is connected here is that should be 11. And the next minimum is that, so 16 is there, so 16 I'm going to be selected. The next minimum is 18, so 18 is going to be selected. And next minimum is, sorry, after 5 it should be 6, right? So 6 is there. So 5, 6, 16 and 18. And if next is that after 16, so it should be 19 is there. So if I'm going to select 19 if the cycle is forming, so that's why I'm not going to select this. And next one 21, 21 also not possible, and 33 is also not possible. So finally I'm going to get this should be the minimum spanning tree, cost spanning tree of the given graph. There are two basic algorithms for finding the minimum cost spanning tree here. So both are should be greedy algorithms. So in this one, so all the time you have to be take out the least cost weight. So first one is that Kruskal's algorithm, and second one is that Prim's algorithm. So in Kruskal's algorithm, we are going to be start with number of nodes, edges in the spanning tree, and repeatedly add the cheapest edge that does not create the cycle. So this is the algorithm what I implemented just now. And in Prim's algorithm, you have to be start with any node in the spanning tree and repeatedly add the cheapest edge and the node it leads to it. So here we're going to be construct the spanning tree to construct both the nodes and the edges. So there are two types of algorithm for constructing this spanning tree. So Kruskal's and Prim's. So the Kruskal's is going to be start with n number of nodes and edges in the spanning tree, and repeatedly you have going to be add the cheapest edge that does not create the cycle. And Prim's algorithm is the under algorithm which is going to be stored with any node in the spanning tree and repeatedly add the cheapest edge. So this is the algorithm for constructing these crystals. So the input should be the connected weight of the graph and output should be minimum spanning tree. So consider a empty spanning tree set of edges and number of nodes in the graph. So repeat this tree until n minus 1 edges is going to be formed. So initially remove an edge from the lowest cost of the dot and then add the vertex to T until P is going to create the cycle. Then discard P, W, otherwise add it. So this is the algorithm normally we are going to be following. And Prim's algorithm, so here it should be a connected weighted graph, output should be minimum spanning tree. So here that spanning tree is nothing but a single node, and then E should be a set of vertices that are adjacent to S. And here also the tree does not contain all the nodes. And how do we remove the edge of the lowest cost? And then if W is already in T, then discard the edge here. So otherwise, add the edge and node W to T. then add those adjacent edges to W also. So what is the main difference between the Prim's and Kruskal's algorithm is that, so in every step we are going to find the minimum weight that are incident to the vertex. So it is already in tree now from the cycle chosen. But when it comes to crystals here, so the minimum weight that are not necessarily to incident the vertex but should be already in the tree now forming the cycle is chosen. Okay, so the Prim's algorithm means so at every step the edges of minimum weight that are incident to vertex is already in the tree now forming the cycle is chosen. And in Driscoll's algorithm, the every step the edges of minimum weight that are not necessarily incident to vertex is not forming the cycle also chosen. That is the only difference between them. So distrust is the person and who is going to be solve uh, the shortest path from point in the graph, some source to destination. So he is the person which is going to find the shortest path from the single source to the other destination. Suppose if I want to find the shortest path from the given node to other nodes in the network, that is one to all shortest path, then Dijkstra's algorithm is going to be implemented. So here a node is nothing but a sorting or initial node here. Then we're going to find the shortest path from the given graph. So I want to find what should be the shortest path from A to E. So for this, so initially I'm going to be select a vertex A, and from this the set of vertices whose shortest path from the source have already determined, and then set T should be the remaining vertices. So Dijkstra's algorithm is going to maintain two set of vertices here. So one is that set of vertices whose shortest path from source is already be determined, and set T should be the remaining vertices. So initially, I'm going to have two sets P and T. So initially it should be empty and T should be a set of vertices. So step one is that uh, label the source vertex 0 and the remaining all the vertices should be infinity. And step 2, so the nodes B, C, D can reach the current node. So these are the node. Among this, so the minimum will have to be considered. So how this minimum is going to be considered here is that, so L of I, so here L of I is the label we are going to be updating and L of J should be the current label. So here in this we have to update the distance values. So how can able to consider this? So the minimum of lower bound is infinity and source vertex from starting with 0, and what should be the minimum of 9? So by adding up the minimum of infinity of 9 is that 9. Similarly, we are going to calculate the L of C and then L of D. So L of C value is going to get the minimum of infinity comma 90, so 90, and infinity of 25. So among this, it should be the minimum one we have to be considered. So now among the nodes of B, C, D, the node B has going to have the shortest value. So that's why I'm going to select this as well. In step 3, so the B is going to be added in the current list. From B, I'm going to find what should be the shortest one from C to C, D, and the E. So let us consider L of C. So from L of C, what should be the minimum here is that. So substitute minimum is 19 is already getting. So 19 plus previous is 9, and then 16. What should be the next minimum I have to consider? That should be 16. So adding up of, so and then I'm going to get what should be minimum of 19 and 25. So I'm going to get 90. So similarly, if I'm going to calculate L of B also, I'm going to get 40. So C is going to be add, and then still are going to select the remaining D and the E. So by updating the labels, so L of D should be I'm getting 24 and L of B I'm going to get 50. So if I'm going to get it, then I can, what should be the shortest path I can able to find from source to all of the vertices I can able to get it. So what are the applications of this distress algorithm is that, so mainly it is going to be used in telephone network, and then should also going to be used in flight to determine the earliest arrival time for the destination of given origin, airport and start time. So these are the references. So here I'm going to say, so the distance algorithm for implementing that. So we need a graph here. So the graph is going to have different types of traversals like breadth first search and depth first search. And Q is the data structure that is going to be used to implement the DFS, and stack is going to be used to implement the DFS. So the spanning tree is this tree which is going to have all the vertices. It does not contain any kind of cycle. And if you consider a graph, then you can able to consider different types of spanning trees here. And mainly this spanning tree is going to be used to find minimizing the cost in electrical power lines, and then water, sewage lines, and telephone lines and all. And for implementing this, we are going to have two kinds of algorithms like Driscoll's algorithms and Prim's algorithm. So the Driscoll's algorithm will repeatedly find out the cheapest edge, whereas Prim's algorithm is going to find the, so this is the algorithm for Driscoll's and this is the algorithm for Prim's. The only difference is that in Prim's, in every step you have to find the minimum edge that is incident to the vertex, whereas in Driscoll's algorithm we are going to be find the minimum weight. And distance algorithm is going to find the shortest one. So how this one is working? So initially take the source vertex, and from the source vertex, so find out the destination one, and take the two sets that should be P and T, which initially should be empty, and the T vertices is going to be considered. In step one, initially you have to add the source vertex A, and remaining vertices should be T. So the L of A value should be source vertex 0, and remaining all should be infinity here. From A, according to this formula, how to find the lower bound value of A. So how can I able to identify this? So the lower bound of n, initially it should be lower bound of b plus L of A plus W of A comma b. So initially it should be infinity. So 0 plus 9, it should be 0 and it should be 9. So I have to find 9 is the minimum. Similarly, I have to select L of B and L of C and L of D. So among all this, I want 9 is the minimum, so I'm going to get it. And similarly, in this one, so next I have to calculate L of C here. So in L of C, the previous 19 is the minimum. So 19 is going to be taken, and then 9 plus 16. So minimum is 19 I'm going to get. And similarly, I'm going to calculate L of E also. And similarly, find out L of D and L of E. So mainly this one is going to be a straightforward curves and right at an agenda. And these are the references here. Okay.
Like, share and subscribe. Hit the bell icon for more updates.